Have you ever run Terraform apply and just watched in awe as it conjures up an entire cloud infrastructure from just a few lines of code? It really does feel like magic sometimes, doesn't it? Well, today we're going to pull back that curtain. We're going to reveal exactly what's happening step by step inside that magic command. Let's trace the journey from your code right into the cloud. So, here's our game plan. We'll start with the command itself. Then dive into how Terraform builds its blueprint, how it checks that against the real world, how it actually executes the plan, and finally, how it records what it did. And stick around, because at the end, we'll wrap it all up with a summary that's perfect for your next technical interview.
All right, it all starts right here, with one of the most powerful and maybe a little intimidating commands in the whole DevOps toolkit. This is the moment we look at our code and tell Terraform, okay, go make this real.
And that's the big question, isn't it? What really happens after you type yes and hit enter? That one little word kicks off this incredibly sophisticated process, all designed to be as safe and predictable as possible. Let's jump into phase one.
Okay, so before Terraform can build anything, it has to read the instructions, right? Phase one is all about understanding your intent. It's about building a complete picture of the infrastructure you actually want to create.
First things first, Terraform scans your directory. It gobbles up all your .tf and .tfvars files, checks for any syntax errors, and then it merges all your modules and variables together into one single cohesive configuration. And from that, it builds something called the resource graph.
And this is the secret sauce, the resource graph. Now, this isn't just a simple to-do list. It's a complex web that maps out all the dependencies between your resources. It tells Terraform, hey, you can't create that EC2 instance until the VPC exists, or you can't attach that security group until the instance is actually running. This graph is absolutely key to making sure everything happens in the right order later on.
Next up, Terraform gets its tools ready. It initializes the provider plugins you need. Think of these as the translators that speak the language of AWS or Azure or Google Cloud. It double-checks the lock file to make sure it's using the exact versions you expect, and then it unlocks their core abilities, what we often call CRUD, the power to create, read, update, and delete resources.
Okay, so the blueprint is done. Terraform knows what you want. But now, it's got to figure out what already exists. This phase is all about that comparison, your code versus the real world.
And to do that, it starts with its memory, the state file. This file, whether it's on your laptop or in a remote backend, like an S3 bucket, is Terraform's single source of truth. It's the official record of every piece of infrastructure it's responsible for.
Now here's a really cool safety feature. Before Terraform even touches that state file, it places a lock on it. If you're working on a team, this is an absolute lifesaver. It prevents you and a coworker from running apply at the exact same time and causing total chaos.
With the state loaded, Terraform doesn't just take it at face value. It performs what's called a refresh. It actually calls out to the cloud provider APIs and asks, hey AWS, my state file says this EC2 instance exists. Is that still true? This is brilliant because it catches any manual changes, like if someone went and deleted a resource through the console, and makes sure the plan is based on what's really out there.
And this slide right here perfectly sums up the core logic of Terraform Apply. It's a simple but powerful comparison. On one side, you have the desired state. That's your code. On the other side, you have the current state. That's the state file, fresh from its reality check. The difference between the two? Well, that's the work that needs to be done.
The result of that comparison is the execution plan. You've seen it a million times. It's that familiar output with all the green plus signs for things to create, yellow squiggly lines for updates, and scary red minus signs for things it's going to destroy. This is your last chance to look it over before anything actually happens.
And now for the main event, the execution. The plan has been made, you've looked it over, and now it's time to turn that plan into actual real-life infrastructure.
But wait, not without your permission. Terraform hits the brakes right here and waits for you to give it the green light with that explicit yes. This is such an important safety feature. It makes sure you've actually read the plan and you're ready to commit to the changes.
So once you give it the OK, Terraform goes right back to that resource graph we built way back in phase one. And this is where that graph really shines. It allows Terraform to work as efficiently as possible, creating independent resources all at the same time, in parallel, while making sure that anything with a dependency is created in the exact right sequence.
And this is where the rubber meets the road. Every single action in that plan gets translated into a real API call made by the provider plugin. So when you create an AWS instance resource, under the hood, Terraform is just calling the AWS EC2 API to create a new instance. It's that direct.
Now, what happens if something goes wrong? Like maybe an API call fails because of a permission issue or something? Well, Terraform has a safety net. It stops everything right then and there. It tells you exactly what went wrong, and it leaves your state file consistent with what it was able to do, preventing a half-finished, broken configuration.
The infrastructure is now up and running, or it's been modified. We're in the home stretch. This final phase is all about bookkeeping, updating the records to reflect the new reality.
With all those API calls successful, Terraform's final job is to update its memory. It writes all the new resource IDs and attributes into the state file, uploads that new state to your remote backend, and finally, it releases that lock so it's safe for the next person to run a plan.
And the very last thing it does is show you any outputs you've configured. Things like the public IP address of a new server or the ARN of a new S3 bucket. It gives you immediate access to the most important info from your new infrastructure.
Whew! We've covered a lot of ground, so let's boil all of that down into a single, crystal-clear summary that captures the entire lifecycle from start to finish.
So here it is in a nutshell. When you run Terraform apply, Terraform first loads your config and reads the current state, putting a lock on it to prevent conflicts. Then it refreshes that state against the real world and generates a plan by comparing what you want versus what you have. After you approve it, Terraform executes that plan, making API calls in the right order based on its resource graph. And finally, it updates the state file and prints out any outputs. That's the whole dance.